Assalamualaikum warahmatullahi wabarakatuh and good morning to Madam Queenie and my dearest classmates. My name is Nur Ain Fakihah Ikilma binti Saiful from Group 1. Today I'm going to present Chapter 1.1 Information Technology. Information technology or IT can be defined briefly as the use of computer hardware and software to store, retrieve, and manipulate information. Advantages and disadvantages of information technology. Some of the advantages are speed, reliability, consistency, storage, communications. And the disadvantages are health risk, violations of privacy, public safety, impact on environment, impact on labor force. Now I'm going to elaborate more about the advantages of information technology. Speed, data, instructions, and information flow at incredibly fast speeds. Many computers process billions or trillions of operations in a single second. Reliability. The electronic components in computers are dependable and reliable because they rarely break or fail. Consistency. A computer with the same input will produce the same results consistently. Storage. Computers store enormous amount of data and make this data available for processing anytime it is needed. Communications. Computers today can communicate wirelessly with other computers. This allows users to communicate with one another. Now I'm going to elaborate more about disadvantages of information technology. Violation of privacy. Personal and confidential records stored on computer were not protected properly. Individuals have found their privacy violated and identities stolen. Public safety. People around the world are using computers to share publicly their photos, videos, journals, music, and other personal information. They will be victims of crimes committed by dangerous strangers. Impact on labor force. Computers have improved productivity. This will make computers replace many labors. Health risk. Prolonged or improper computer use can lead to health injuries. Behavioral health risks are computer addiction and technology overload. Impact on environment. Computer manufacturing processes and computer waste are destroying natural resources and polluting the environment. Applications of information technology. Fields: education, finance, government, healthcare, science, publishing, travel, and manufacturing. Now I will elaborate more about applications of information technology. There's a few of examples that we can conclude in education. For example, is learning management system. Is a software that contains tools for class preparations, distributions, and management. Through the course management system, students access course materials, grades, assessments, and a variety of collaboration tools. Computer-based training. uses computer-generated visual or environment for training, such as flight simulator used by pilots before flying new planes or different types of planes. There's a few of examples that I can conclude in finance. First, online banking. Users can access account balance, pay bills, and view monthly statements. Finance investment system. Investors can buy and sell stocks and bonds online without using broker. There's a few examples in government. First, HRMIS, Human Resources Management Information System. It's about online system for updating government employee information. E-Sharia, online portal for providing information to public of members of the Sharia court to get the latest information about rules and procedures of the court. E-Filing, online system for declaring tax. E-Filing, online system for declaring tax. In healthcare, there's Medline. Many websites provide up-to-date medical fitness, nutrition, or exercise information. Counter registration system. Hospitals and doctors use computer and mobile devices to maintain and access patients' record. Telemedicine is the use of telecommunication and information technology to provide clinical health care from a distance. It has to be used to overcome distance barrier and to improve access to medical services that will often not be consistently available in distant rural communities. In field travel, there's examples of applications, and one of them is GPS, Global Positioning System, IT applications that helps users to track routes for specific location. Automatic roaming system, telecommunication company provides in automatic roaming for travelers to travel aboard. Online reservation system, a transportation and communication reservation can be done through websites. In science, virtual reality or VR, the use of computer to simulate a real or imagined environment that appeared as 3D space. Examples of virtual reality application is VR headset, PlayStation VR, surgery simulation, flight simulation. Hawk-Eye, officiating system, computer system used in sort of such as tennis and badminton to visually track the ball from different angles and display a record on it. In publishing, there's online newspaper or magazine. Use of it allow people to read newspaper or magazine online. Online photo card printing. Use of it allows people to send editing and printing through online. In manufacturing, computer-aided design (CAD) create, modify, analysis, and optimize a design through the use of computer system to increase designer productivity and design quality. Computer-aided manufacturing controls machine tools, mainly robot arm, in high-tech assembly lines. There's 6 types of category of computers. First, it's supercomputer, mainframes, personal computers, mobile computers, mobile devices, embedded computers. Now I'm going to display some of the videos that will make you guys understand more about these type of computers.
Computers are all around us. From laptop computers to smartphones to smartwatches, they're changing the way that we live our lives. But have you ever asked yourself, what exactly is a computer? A computer is an electronic device that manipulates information or data. The computer sees data as ones and zeros, but it knows how to combine them into much more complex things, such as a photo, movie, website, game, and much more. Computers use a combination of hardware and software. Hardware is any physical part of the computer, which includes the internal components and the external parts like the monitor and keyboard. Software is any set of instructions that tells the hardware what to do, such as a web browser, media player, or word processor. When most people say computer, they're talking about a personal computer. This can be a desktop computer or a laptop, which has basically the same capabilities, but in a more portable package. Personal computers come in a few different styles. The most common type uses the Windows operating system. Macs or Macintosh computers feature the Mac OS operating system, while Chromebooks run on Chrome OS. Smartphones and other mobile devices mostly use the iOS or Android operating systems. We'll talk more about operating systems in a later video. Computers come in many other shapes and sizes. TVs, game consoles, and even appliances like refrigerators can have built-in computers, although they may not do everything a desktop or a laptop can. There's another type of computer that plays an important role in our lives: servers. A server sends information to other computers on a network. In fact, every time you use the internet, web servers deliver the web pages that you want to see to your computer. Servers are also used in many offices to store and share files. As you can see, there are many types of computers out there, and each one plays a part in our modern world.
GCF Global, creating opportunities for a better life.
The race for the world's fastest supercomputer is on. China held the lead for the last 5 years, but the United States has surged ahead with Summit. It's a $200 million government-funded supercomputer built for Oak Ridge National Laboratory in partnership with IBM and NVIDIA. But what is a supercomputer? Today's supercomputers are comprised of thousands of connected processors, and their speed has grown exponentially over the past few decades. The first supercomputer, released in 1964, was called the CDC 6600. It used a single processor to achieve 3 million calculations per second. While that may sound impressive, it is tens of thousands of times slower than an iPhone.
If you have a smartphone, it is more powerful than the supercomputer that we had back in 1995 doing human genome.
Today, Summit consists of over 36,000 processors from IBM and NVIDIA that can perform 200 quadrillion calculations per second.
What a typical computer will do in 30 years, this machine will do in an hour.
Summit takes up 5,600 square feet of floor space and has nearly 200 miles of cable. It uses 4,000 gallons of water per minute to stay cool and consumes enough power to run 8,000 homes. But why do we need such fast computers?
It has tangible results in terms of how it helps society at large. It will translate into better appliances, better security systems, better delivery of power, more efficient homes. Every aspect of life, it'll change.
Supercomputers are used across all sectors, forecasting weather and climate trends, simulating nuclear tests, performing pharmaceutical research, and cracking encryption keys. Summit is the first supercomputer designed for artificial intelligence applications, and researchers plan to use Summit for AI projects that could identify genetic predispositions to cancer or opioid addiction. By surpassing China, the US has escalated the tech rivalry between the two countries.
There's no question the race is on. But this is not the space race. This is the race to knowledge.
But faster supercomputers are already on the horizon. The European Union, Japan, and China are all developing machines they say will outperform Summit. The next big frontier is exascale computing. That is, computers that can perform 1 billion times 1 billion calculations per second.
The use of this machine is only going to be limited by the imagination of the scientists who will have access to this machine.
Hey there, thanks for checking out CNBC on YouTube. Be sure to subscribe to stay up to date on all of the day's biggest stories. You can also click on any of the videos around me to watch the latest from CNBC. Thanks for watching.
What comes to mind when you hear the words big iron? Heavy construction? Extreme laundry? My nickname in high school? Well, it turns out that big iron is none of those things and usually refers to mainframe computers, massive machines that typically live inside of large cabinets. Okay then, Linus, so you're talking about a supercomputer, right? Actually, no. Mainframes are defined a little differently. In our episode on supercomputers, which you can check out here, we discussed how they are great at number crunching to complete extremely complex tasks like weather forecasting, medical research, and cryptanalysis. But with mainframes, the focus is more on throughput and reliability. So what exactly does that mean? Well, compared to something like a supercomputer, mainframes have a lot more inputs and outputs, or I/O, because they're often deployed in situations where they aren't working on one massive complex problem, but rather they have to process tons of smaller, simpler transactions extremely quickly. In fact, even though there is a popular misconception that mainframes are relics of a bygone computing era, to process the up to millions of card swipes and account transfers that occurred daily, 96 out of the world's top 100 banks and 23 out of the top 25 US retailers currently run mainframes from IBM, who has been the dominant player in the industry for a very long time. Building one, though, isn't just a matter of installing a whack ton of Xeons in a box, plugging in lots of Ethernet cables, and calling it a day. Mainframes use special CPUs, many of which are much larger physically than even big desktop chips like 2011 socket CPUs from Intel, as well as additional processors called System Assistance Processors, or SAPs, that do almost nothing but move data around as quickly as possible, like glorified traffic controllers, rather than general-purpose number crunchers. And that's not all. On a modern mainframe, like the top-end IBM Z13, each individual I/O card, of which there can be 160, has its own processing cores, up to 2 per channel on the dual channel cards, meaning you could have over 600 processor cores just for I/O, and that's not even counting the SAPs. Whoa. Part of the reason that modern mainframes are designed to support this much I/O is to ensure that they stay reliable. So many of the subsystems inside a mainframe, like a modern airliner, would have redundancies built in. This means they can be deployed in situations where zero downtime is acceptable, such as the aforementioned credit card companies and retailers, as well as airline ticketing systems. In fact, a common mainframe operating system, IBM's proprietary ZTPF, was originally developed as transaction processing software for airlines. If you want to see it in action, pay close attention next time you board a flight, and you might just get a glimpse of the computer screen they're using to check you in. An old-school interface with green text indicates that it's probably a terminal connected to a mainframe. Just don't look too closely at it. So this high level of redundancy means that it's common for mainframes to be built in such a way where an administrator can slide out one of the drawers that houses components and simply start swapping them out. Whatever that drawer was working on is automatically transferred over to the rest of the mainframe, making it easy to make necessary hardware changes without any downtime. Which is a good thing too, because high-end mainframes can run tons of virtual servers at once, up to 8,000 in the case of the Z13, meaning that taking down the mainframe could result in a lot of transaction errors on Black Friday. But before you start thinking, gee, I should get myself a mainframe because I want to run Overwatch on like some kind of 50-monitor setup, mainframes and their operating systems aren't just absurdly expensive. A single mainframe can cost hundreds of thousands, if not millions of dollars. They also aren't designed to run games or for high-end floating point performance, which is important for rendering graphics. But even so, mainframes are still in the background, powering lots of things you do every day, which is pretty cool. That is, unless you've sworn off air travel and you don't want MasterCard to know about all the weird stuff you buy on Amazon. Speaking of having your online activities tracked, TunnelBear VPN lets you anonymize yourself on the internet and browse the internet and use online services as though you are some anonymous guy in some other country. They have easy-to-use apps for iOS, Android, PC, and Mac. They also have a Chrome extension, and it's super easy to use. You just press a button and boom, TunnelBear's on. Your connection gets encrypted with AES 256-bit encryption, and your public IP address gets switched, so you show up as though you are in a different country. TunnelBear makes it easy by bypassing all the annoying details that typically come with using a VPN. No DNS, no router configuration, no port configurations, none of that nonsense, and they've got a top-rated privacy policy and do not log user activity. So try it out for free with no credit card required at our link in the video description, and also by using our link, you can save 10% when you sign up for a year of unlimited. So that's tunnelbear.com/Linus. So thanks for watching, guys. Like, dislike, check out our other channels, comment with video suggestions, and subscribe. Don't forget to subscribe. That's the most important part. That's why I said it at the end.
No matter where you go or what you do, an embedded system is helping you, serving you, protecting you. Embedded systems are computer components which interface with and control mechanical and electrical systems. They often rely on sensors, like an airbag in a car, or a human interface, like pushing a button, to perform a specific task. Unlike general-purpose computers which perform multiple tasks, embedded systems are designed to do a specific task. They can be large enough to run a factory assembly line or small enough to fit in your watch. And they can be found in every industry on the planet. A few examples: finance, defense, home appliances, computer electronics, automotive, business and manufacturing, medical. If you think mankind just couldn't develop another type of embedded system, think again. The outlook for the embedded system industry is bright and very positive.
From the videos that I've shown, we can describe the characteristics and capabilities for every categories of computers. Supercomputer. The physical size Size of supercomputer occupies a full room of equipment, and the speed is 10 of thousands of processors, and the storage extremely large. Storage. In mainframe, the physical size of mainframe occupy partial room to a full room of equipment, and the speed dozens of processors, and the storage very large and adaptable storage. Personal computers. The physical size, the size of personal computers fits on a desk, and the speed is a single processor, and the storage is large. Mobile computer physical size. The size of mobile computers fits on your lap or in your hand. Mobile devices. Mobile devices such as smartphone size is fits in the palm of your hand or pocket size. Embedded computer miniature. It is mounted on a circuit board and then installed in a machine or appliance using wires to carry input and output signals. That's all from me. Thank you for watching. If you have any questions, feel free to put in the comments. Thank you.